When we think of random numbers, we often think of something like rolling dice, flipping a coin, or shuffling a deck of cards. Random numbers add a degree of interest to games because every game is then different. Variation makes computer-generated art more realistic and computer-generated voices more natural. Random numbers are also useful in simulating the complex events of the real world in Monte Carlo simulations, named after the famous casino in Monaco. Another application is for encryption. When you do a transaction on your bank account, you don't want anyone else monitoring it. These are all things that we want to do on a computer these days. Typically, a computer rolls a virtual dice with 1 billion or more sides, which can be considered as a number between 1 and 1 billion, or, more commonly, a number between 0 and 1. We can then use formulas to translate this into another type of random number, like drawing the next card from a deck, which we might represent as a number between 1 and 52. To generate truly random numbers, you need a non-predictable hardware circuit, like measuring the voltage of a Zener diode that generates random noise, quantum effects like the rate of radioactive decay, or recording the instance in time that somebody types a character on a computer keyboard, or using an unstable circuit like a ring oscillator. Perhaps surprisingly, it's often difficult to get enough randomness from sources like this, so we use computer programs called pseudo-random number generators to produce an indefinite supply of numbers that look random enough for our purposes. Computer pioneer John von Neumann said, "Anyone who considers arithmetic methods of producing random digits is, of course, in a state of sin." Using predictable circuits such as we have in a computer always produces a predictable result, if you know the program and the inputs to the program. But this is quite good enough for allowing a computer to simulate rolling a dice, flipping a coin, doing computer animation, or creating a model of the motion of stars in our galaxy. Most computer languages have a built-in random number generator, which is purely software. This depends on having a random seed as a starting point, and then repeatedly applying a program which modifies this to produce a new number, which looks quite different from the previous number. A good random number generator won't generate the same sequence of numbers for a very long time. One popular method takes a starting number and uses just one multiplication, one addition, and one division to produce another number which looks quite different from the first one. By applying the same equation over and over again, you can generate a sequence of numbers which looks quite random, unless you happen to know the starting number and the equation, and then it becomes entirely predictable. To prove that a number is quite random, well, think of a dice. If the dice is fair, all of the numbers from 1 to 6 will come up, and roughly as often as each other. For a computerized random number generator, mathematicians apply an exhaustive series of tests, like the following. We know that numbers from a computer will eventually repeat, but how long does it take to repeat? It should be as long as possible. Do all of the numbers from 1 to 1 billion come up? If a particular number comes up again, is it always followed by the same number? There are statistical tests to verify that all the numbers come up approximately the same number of times, but not exactly the same number of times, because that wouldn't be random. You expect to find numbers getting larger or smaller with equal probability, and if you take a single bit of the number, it's a 1 or a 0, like flipping a coin. Now, some bits of the random number generator may not be as random as some other bits. The random numbers may appear random if you look at every number, but are they still random if you look at every third number or every 12th number? Probably the most demanding application of pseudo-random numbers is encryption, because a hostile person may be willing to spend a lot of money and computer time on cracking the code and trying as many seeds as possible. For this reason, the US and German governments have published rules listing the actual tests that must be passed if a random number generator is to be used for various purposes. Some new computer chips have hardware to generate genuinely random numbers, and this is built in, which will help them generate an unlimited supply of random numbers to make our modern computerized lives just a little bit more interesting.